time, and I'm Canadian, so I tend to talk a lot. But then we apologize for it afterwards. So it's going to be okay. Okay. F5, you said? There we go. Okay. My name is Amir Ahmed. My colleague, Michael Carter, is in the back there. So first of all, thank you for inviting us to talk to you today. We're pretty excited about just really introducing you to some of the work that we did this past summer. I should also mention that Dr. Neil Ferris couldn't be here today. He's our supervisor and kind of a point on this project. So I'm going to introduce to you something called sustainable archaeology and the work that Mike and I did over the summer at Sustainable Archaeology in 3D mass digitizing of artifacts. And that took us in a number of surprising directions that we'll talk about right now. Oh, that's us. That's Neil on the top there. So Sustainable Archaeology is part of the funding was given to Sustainable Archaeology by the Ontario government and innovation.ca. This is the facility here. It's a $10 million facility that just went up this past year. And it was built to combat a growing problem in southern Ontario, which is likely a problem in Europe as well, which is archaeology is tied to land use development. So the more your population grows, the more houses you need, the more archaeology you need, and the more artifacts you end up with. And in Ontario, there's no real organized way to store all of these artifacts. So what you end up with is a situation where artifacts are stored in boxes in people's basements, in attics. You know, there are stories of an archaeologist will die and their spouse will take those artifacts and pave their driveway with it, not knowing what it is. It's really, really awful stuff. So this is what that kind of looks like. Just a mess of cardboard boxes. It's just awful. So Dr. Neil Ferris and his co-principal investigator, Aubrey Cannon from MAC, wanted to turn this into this, which is an organized system to grab all the artifacts that is being produced by the CRM industry in Ontario and to compile it all under one roof in one facility. So this is the Sustainable Archaeology Facility at Western U. So what that lets you do, once you sort of put together a system and a workflow to start bringing in artifacts under one roof, you can make all of those artifacts available and accessible to people. And that's a core part of the sustainable archaeology vision, is accessibility through digitizing. And it's great to kind of hear all the other talks because a lot of that stuff is really sort of where we're heading. And in Southern Ontario, not a lot of people are doing this. So, I feel kind of like, this is my tribe because nobody else, I'm really happy to be here. Okay, so let me just quickly take you through the process of an artifact going from a dig to storage. So basically, an excavation, somebody pulls out an artifact, and they're processing it, they put it in a bag, they put it in one of our plastic green boxes, which isn't going to degrade over time. They put a tag on it, a DM code, so we know where it comes from. They send it over to us, and at that point, one of two things happens. It's either put away in storage, so on one of those shelves, or it goes through a more intense digitizing process. So artifacts that are diagnostic, otherwise complete, or just really interesting, go to the Sustainable Archaeology Animation Unit. Mike and I both have a computer animation background. Mike is an 18-year TV industry and film and television, CGI, special effects industry veteran. I used to be a storyboard artist. So we're coming at this as sort of a media creation perspective. So this past summer, and these are some of our sponsors. We were able to get about $30,000 for our pilot project. So this past summer, we pulled 10 computer animation interns from Loyalist College in Southern Ontario, second year and third year. So they had a bit of a technical background behind them. And so we pulled them into the essay with the task of figuring out a system for 3D digitizing. That was it. So these are our 3D3 white light scanners that we used. We have 4 of them. Oh, that's better. We have 4 of them. And we spent about, I would say, better part of a month figuring out how to get these operational. But once we did, we set an amount of time for ourselves. We said, okay, we're going to give ourselves 3 weeks, and we're going to scan as many artifacts as we possibly can. So we were able to scan just under 400 artifacts in 3 weeks. So, which we think is probably where we need to be in order to fill our database full of digitized artifacts. So this is kind of what that looks like. So we start with the artifact, we get a model, then we apply some high-res textures on top of it. The scanning process is actually relatively fast. If it's a complex artifact, then it could take probably about 20 minutes to do 100 individual scans, but probably no more than that. So the entire process, including scanning, hole filling, post-processing, probably takes about an hour and to an hour and a half for more complicated artifacts. Simpler, more straightforward artifacts can be done in about half an hour. So even though we were working at a rate of about 6 or 7 per day, depending on the artifact, you can increase that by double. So once we had this as a digital version of an artifact, we kind of started to think about where are we going to go next. So at this point, we stole a term that we got from game design, which is digital asset. So this is a virtual artifact. It's a digital asset. Now we can kind of take it and point it to a number of directions. And we had computer animation students who were like, well, let's make an animation. So we start off with this. This is one of our artifacts. So this is an actual 3D model of a scanned artifact with high resolution textures on it. And that was done fairly quickly, so we moved on to something more interesting. This is the end of a longhouse. And so we decided to animate shingles going onto the longhouse. We're associated with a museum, the Museum of Ontario Archaeology in London. And they need teaching resources. So they asked us to develop a flyover. Once they saw this stuff, they asked us to develop a flyover of a 15th century native village called the Lawson site, which is behind the museum. So we spent some time to do that, and this is it here. This is kind of a lower resolution version. So what we wanted to do was actually animate very specific things. So things like a longhouse being built, the palisade going up, what that environment may have looked like, the interior of the longhouse. What's interesting about this is that a lot of the objects in the longhouse are actual artifacts. So there's a direct connection between digitization and media. So that's done. So, and the internship was 14 weeks. And at this point, we were about halfway through, so we're like, well, what are we going to do now? So we decided to put it into a game. Oh, that's footsteps. That's funny, I didn't know that was there. Okay. I was like, someone just knocking on the ceiling. So we took all those digital assets and we brought it into the Unreal Engine. And this is going to go on a kiosk in the museum. So right now, the user is actually going through this. Those little green leafy things are information nodes. So I presented this to a high school, and it was a talk about digital archaeology. You know, it's really funny. You're not going to see this, but when you die, you actually see robot legs. Okay, so I was presenting this to a class, and the talk was about digital archaeology and archaeology in general. And I showed this to them, and it was done. Like, the talk was over. They pushed me off, and they just like played with this for about half an hour. So it really shows you how effective using this type of media can be to engage with the public for archaeology. All right, I'm just going to move on here. Okay, the other thing that we looked at was, can you see that? Okay, it's kind of dark, but that's okay. The other thing we looked at was...
Lights back down? Street lights, but...
yeah, sure, that might be...
Sorry, Dan. You might break everything.
Am I losing time right now?
Yeah, but don't worry.
Perfect.
You happy now, though? Oh, we'll just go from those.
Perfect. Okay, great. Yeah, I'm just this disembodied voice talking. So this, how many people are familiar with Minecraft? Okay, good. That's more than I thought, actually. So we created the Unreal Engine. Sorry, we didn't create the Unreal Engine. We created the game that we put into the Unreal Engine. And then we started to sort of think about ways that we could push that. What else can we do in these kinds of environments? So I asked one of the interns to start building something in Minecraft, and they started doing this. So for those of you not familiar with Minecraft, it's essentially digital lingo. So it lets you create things, it lets you build things digitally, but things also have real world physics. You can interact in really surprising ways. So we thought it would be neat to kind of so right now that's the Palisade. We thought it would be really cool to kind of see what happens if we set this on fire digitally. And we couldn't get it working, and we're like, why is this thing not setting on fire? And we were like, wait a second, it's raining. So it goes to show that there's a real kind of direct connection between real world physics and something that you can build to engage with the public, which is something that I don't think has ever been explored before. So those are some of the things that we were working on this past summer. So Mike, have I forgotten anything? I feel like I might have. You shaking his head. Okay, thanks. Okay. So at this point, we were kind of like, well, where are we going to go next? And the title of this talk is The Internet of Things, Digital Artifact Ecosystems, because we should have had this already, but we don't have it yet, but we're getting a 3D printer at Sustainable Archaeology that should be here probably in a month or so. And so we realized that once we had a digital asset, we could then print out these artifacts, right? So once we print them out, you can do a lot of things with them. So just a word about the Internet of Things. How many of you are familiar with what that means? Okay, all right, good. So let's go over it really quick. So the Internet of Things was a concept that came about in the late 90s, and it basically describes a way for computer systems to talk to real things. So the original idea was to use RFID tags for that to happen. And that was 13 or so years ago. So essentially in 1999, that was just for really inventory purposes. So we're at Internet of Things 2.0, maybe even 3.0, where it's more than just inventory. So at Sustainable Archaeology, we're certainly doing inventory. All of our boxes are RFID tags, so we know where they go within the facility. All of our artifacts will have DM codes attached to the artifact in some way, so you can scan it and get information. But where else can you put this technology? What else can you do with it? So we thought it would be perfect for public digital engagement. So let me just run you through a scenario that we've played around with. Let's say, for example, at the museum, you print off a bunch of digital artifacts. Each artifact is unique, and you give one to a student. Each artifact has a DM code on it, or an RFID tag, or maybe an NFC sticker on it, which means that it can interact with other systems. So that artifact is theirs for life. Now let's say that they take that artifact and they go to another museum, and this additional museum has a display that can read that artifact. So what we are thinking is that it could look something like this. So what this is this is your artifact. This is your digital recreation that you've taken to, say, the British Museum. You've taken it to a display of an artifact from Egypt, and you go, beep, you check in, and this display comes up with your artifact on a timeline, and compared to the artifact that you checked in at on the same timeline. And information in the middle which compares the two. So what that means is this is contextual information. It's unique to you and your artifact. So every time you take your artifact and check it into a display, that experience is different because your artifact is yours and the information attached to your artifact is yours. So we think that's quite cool because what that means is you're interacting with the archaeological record in a very unique, very personal way. It means that artifacts can live multiple lives. Artifacts aren't tied to geographic restrictions. In Southern Ontario, we tend to think of archaeology just as Southern Ontario. Now you can take your Paleo-Indian point to Arkansas, check it in there, and compare it along whatever this timeline might be, and figure out points of similarities, how they differ. I should say that this is just one example. Once you start creating data that's completely open, Adam talked about, it's Adam, right? Okay, perfect. So Adam talked about the history of London in 10 artifacts. I know the British Museum has history of the world in 100. So imagine if each one of those was 3D printed. Now you can interact with this stuff in a very, very unique way. But it all depends on creating an open framework to support this. And from our perspective, that starts with mass object digitization and that next step, which is that media creation part. So that's why we're kind of excited to be here, because we think this is a good opportunity to start talking to people about how we can make this happen, because we think this is actually quite worth it. So let me just end up by saying that, oh, perfect. So let me end up by saying that in Canada, First Nations people have told archaeologists that artifacts have voices, have essentially spirits. So what we want to do is we want to take those spirits and voices and make them accessible for everybody. Thank you.